This is chapter 6, section 1. This is called solving systems by graphing. So our objectives are to solve systems of equations by graphing, and then to analyze those special systems, like basically special situations. Okay. Here's what we want you to write down for this little section is two or more linear equations form a system of linear equations. Any ordered pair that makes all of the equations in a system true is a solution of that system of linear equations. So basically, what we are saying is, if you take two or more linear equations, and what we're basically talking about is equations that have an x and a y, right, that represent a line. If you take two or more of those and I don't want to say combine them, but pair them together, that's called a system of linear equations. Now, any ordered pair where, like we're talking an x, y for right now, any ordered pair, when you plug those numbers in, if it makes all of the equations true, that's called a solution. So there are a few different ways of doing this, and the next few sections are going to go through those different ways. But today what we're looking at is finding the solution by graphing them. Okay, so here's what we mean by that. We want to solve the system of equations by graphing. So we are going to graph these two lines right here. So the first one has a y-intercept of 2. So I'm going to put a point right there. And the slope is 1. So that's 1 over 1. So that's up 1 over 1. Up 1 over 1. Up 1 over 1. Okay. And our line will look like this. Okay. And then the next one is -2 is our y-intercept. And the slope is 3, so that's up 3 over 1, up 1, 2, 3 over 1, 1, 2, 3 over 1, 1, 2, 3 over 1. Okay, so now what I suggest to you while you're doing this on your paper is to grab some kind of a straight edge. Now we might be talking a ruler, we might be talking just a piece of paper, but grab some kind of a straight edge to make a nice straight line for this. Okay? Now your solution is wherever these two lines intersect. And so they intersect right here, which is at the point 1, 2, 4. So our solution is 2, 4. Now, do we know that we did that right? Well, we can check. And we can check by plugging these numbers in. So I'm going to take my first equation, y equals x plus 2, and I'm going to replace the y with 4 and the x with 2, and find out that it becomes 4 equals 4. So that's right. How about the next one? 4 equals 3 times 2 minus 2. That's 4 equals 6 minus 2, which is 4 equals 4. So this solution was true and made both of these true. And so therefore that's the way to check it. So this is checking our answer. So there is our solution, 2, 4. Let's try this again. What's the solution of the system? So we have to graph these. So we start with plus 3, 1, 2, 3. Our slope is -3. So we go down 3, 1, 2, 3 over 1, 1, 2, 3 over 1. Let's do one more. Okay. And -7 is our y-intercept, and our slope is 2, so up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. So if I graph these two, pretty close, and I graph these two, we find that our solution is right there at 2, -3. So our solution is 2, -3. And we're going to check this. So we plug this back in. So y is negative 3, x is 2, plus 3. Negative 3 equals negative 6 plus 3. So that's negative 3 equals negative 3. So that one works. And the second one is negative 3 equals 2 times 2 minus 7. Negative 3 equals 4 minus 7, which is negative 3 equals negative 3. So they both work. And so that tells us that this is indeed our correct solution. All right. So what if this turns out, we have a word problem where we have to do this? So scientists studied the weights of 2 alligators over a period of 12 months. Their initial weight and growth rate of each alligators are shown below. After how many months did the alligators weigh the same amount? So first alligator, his weight is going to be our y's. So this is our weight, and this is going to be the time, is the x. So initial alligator, his weight, which is going to be y, equals his growth rate was 1.5 per month, and he started at 4 pounds. So there's the equation for alligator 1. Alligator 2, his weight will equal 1 pound per month, and he started at 6 pounds. So if we graph these two, first one is start at 4, and our slope is 1.5 over 1. 1.5, it's the same thing as 3 halves. So I'm going to switch it to 3 halves. So that's up 3, 1, 2, 3 over 2. 1, 2, 3 over 2. And there's our line. And this one is plus 6. And it's up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. And you see where that is, oops. You see where that's going to intersect this right up here, and that is 410. So what that means is, after how many months did the alligator weigh the same amount? So which one of these two numbers represents the time, the amount of months? The 4. So our answer is 4 months, and it's when they are going to be 10 pounds. At 4 months, they'll both be 10 pounds. So a system of equations has at least one solution is called consistent. Those consistent systems, I would write this whole thing down, can be either independent or dependent. A consistent system that is independent has exactly one solution. And so far that's what you've seen so far. But a consistent system that is dependent has infinitely many solutions. Or if the system of equations has no solution, it's called inconsistent. Okay, so it can be consistent or inconsistent. If it's consistent, it can be either independent or dependent. And we're going to show you what those two look like. So let's take these two equations and let's graph them. So in order to do that, we're first going to convert this back to slope-intercept form. So I got 2y minus x equals 2. I'm going to add x to each side. So I get 2y equals x plus 2. Divide both sides by 2. So that means we get y. This 1x becomes 1/2 x, and 2 over 2 becomes a 1. So if you see, they are both the same equation. So there's my y-intercept, which is 1. My slope is up 1 over 2, up 1 over 2, up 1 over 2. And so there is our first line, best I can. And now, if I graphed my second line, it would be the same thing, right? So you see, that's pretty bad. Let's try it again. That's even worse. Pretty good there. So you see when I graph two lines, so second line, first line, they're the same thing. So what that means is, if they end up being the same line and on top of each other, they have infinitely many solutions. So what is a solution? Infinitely many solutions. Okay? How about this one? Okay, let's graph both lines. So the first one is y-intercept at plus 2. Slope of 2, which is up 2 over 1, up 2 over 1. Next line, so y-intercept of negative 1, so that starts here. Slope of 2, up 2 over 1, up 2 over 1, up 2 over 1. Line's going to look like this. So what you see is these lines are parallel to each other, which means that they will never intersect each other. So when the lines never intersect each other or are parallel to each other, they have no solution. So again, never intersect each other, no solution. Same line, many solutions. And if they only intersect in one spot, that ordered pair in which they intersect at is your one solution. That is what this section's all about, a lot of graphing, and then just knowing the difference between the three.